talking about how we take all of this threat data and actually use it to enforce that against traffic patterns in our network. So once we detect that a host is compromised, how do we prevent lateral propagation, for instance? We're going to look at this in the context of the broader connected security application. Specifically, in this case, we're going to look at the application to the multi-cloud. So actually, going back to this previous slide, once we detect that a host is compromised, we want to quarantine it. And we can integrate with our MX routers, EXQFX switches, as Crystal mentioned, a number of NAC solutions as well. We can also integrate with cloud providers to do the same thing. That's what we're going to look at here. So first, I want to talk a little bit about the challenges specific to enterprise cloud environments, specifically those where an enterprise is working in multiple clouds. Now, there's a lot of good reasons you might want to do this. Most of those revolve around cost. So organizations that are moving to the cloud, they're already making a trade-off. They're trading flexibility. So they're gaining some flexibility. They're reducing their CapEx, but they're probably going to end up increasing their OpEx, at least in the short term. What they're trying to get out of that is flexibility and the ability to dynamically scale their applications without having to put a truck on the ground and actually deploy new hardware. But you end up with this environment where you have your applications stretched across multiple cloud silos. So you've got some applications over in Azure, you've got some in Google Cloud, you've got some in AWS, of course. You probably still also have some applications running on-prem, maybe inside of a vSphere cluster. And what we want to do is get away from having to manage multiple separate clouds towards managing one cohesive multi-cloud system as though it's just one set of resources. We want to treat it all the same way. And of course, what we're going to be looking at here is how we can address the security component of that. Because all these different cloud providers have their own security models. We don't want our engineers to have to relearn everything, to learn the AWS model, the Azure model, the Google Cloud model. What we propose instead is to use our virtual firewall, the VSRX, which is currently available in AWS, Azure, and Google Cloud, to act as the security endpoint for our cloud resources. So this can simplify enterprises that are trying to move to the cloud. They can take their existing management systems, like Security Director, which we can use for managing our SRX firewalls. They can take their existing policies even, a lot of their existing procedures, and just by parking their resources in the cloud, protecting them with the VSRX, they can extend their existing security, including advanced threat protection, which we were just talking about, to secure those cloud workloads. So we're overcoming some of that complexity. So how do we actually accomplish this? It's really all built around tagging and metadata. So one thing that all these clouds have in common, AWS, Azure, Google Cloud, they all have similar concepts with different implementations. And one of those concepts is metadata associated with cloud instances. So when you deploy a VM or a container to AWS, you can associate a set of tags with it. Those tags will tell you what sort of infrastructure requirements it has. So it might require a CPU-intensive instance or a memory-intensive instance. It will tell you what tier of the application that service is part of. Is it a backend? Is it middleware? Is it client-facing? And you can take that information and then use it across multiple departments. So we go on to the next slide here. Here's an example of what a workflow for that might look like. And this goes back to the topic Crystal talked about way at the beginning of how we sort of work across these typically siloed concerns. So we have development, operations, and security. They all have separate and sometimes conflicting needs. Development wants to get their releases out as fast as possible, right? And as we were talking about, they think of the network as just dumb plumbing. Operations is actually all the smarts behind that plumbing, right? Making sure packets get effectively from point A to point B. They want to make sure that new versions of applications or new services we have to deploy don't break what's already working. Security, of course, is looking to protect our data, protect our applications against malicious activity. And using this metadata gives us a way to unify all these operations. Obviously, it's not a magic bullet, but this can help. So we start by having development when they're creating their services. So here we have an example of just a simple API that uses a SQL backend. And when they define these applications, whether they're virtual machines or containers, they're going to associate this metadata with those applications. So here we have a name tag, a tier tag, a department tag, and a PCI tag. So this application is dealing with financial information. Then we have on our SQL instance, it's different tier. So it's in the data tier. It's going to be backend. So might not have, for instance, direct internet access. And PCI here is going to be true. We're storing, in this example, credit card information in there. So development, they set those tags and they can forget about it. Now it's operations' job to provision those resources based on those tags. So they're doing the work of figuring out what is most cost effective and best for performance. And there are a lot of considerations here, throughput being an obvious one. Also, geographical availability. So some applications might need to be located in specific places. PCI applications, especially, might need to be in specific geographies to meet compliance requirements. So they can use those tags without necessarily knowing any of the low-level details of the application to know where to deploy those instances. So in this example, we're deploying our SQL instances on AWS in the US West 1 availability zone, in this case, in a VPC called AWS main. But our API service, we're deploying in Azure. Maybe there's a cost consideration there. It might just be cheaper and more efficient to do so. Then operations hands things off to security. And with security, and this is where the policy enforcer that we just introduced really comes into play, we can create security policies, and part of the actions in those policies include ATP scanning with the advanced anti-malware policy, or SecondTile, little typo there. And we can create policies that instead of matching on subnets or even zones in some cases or IP addresses, they can match on these tags. So we can have a policy already in place that says, hey, traffic within the finance department. So for instances, they're both in finance, from my API to my SQL, I'm going to allow that. Notice there's no IP addresses in here, nothing about where that's located. So security can take that one policy and apply it to instances as they're spun up across multiple cloud environments. And this is all enabled by using our SRX for security enforcement and the policy enforcer for actually dynamically creating the address groups that the SRX actually uses based on these tags.
So a question just on the different teams that you've got there.
Yeah.
And the use of the tag. So from the way you were describing it, sounds like there's a bit of a handoff between separate teams and they don't need visibility of what's going on between those. So I guess my question is, how much visibility would I have as development into what the implications of my tagging this service would actually be downstream?
Yeah, so what you're raising there is really one of the organizational challenges with trying to unify these different silos. And different organizations are going to address this in different ways. So if you're looking at a smaller company, these teams probably work closely together. They're not fully isolated in these silos. There's not this perfect separation. Larger organizations are naturally going to be more siloed. This is to help us be able to overcome some of that siloing. So it's hard to give you a perfect answer to that question because it's really going to depend on what you need as an organization and really what the skill sets of your development, operations, and security teams actually look like.
Okay, so but if I'm as a developer, so if I'm in development, when I'm applying a tag to a service, how do I actually do that?
It depends on what it is. So if it's a container, say you're running on a Kubernetes service, there's a whole metadata functionality built into that. So every time you define a pod, you assign metadata tags to it. And it's very flexible. They're just key value pairs. For anything based on a virtual machine, then it would be in the definition of that VM that you're shipping out. Could be just in a YAML file, which then operations will take and turn into a definition for that VM in AWS or Azure. Some organizations, the development team might be choosing themselves where it's going, whether it's going into AWS or Azure, in which case they might be writing, say, a CloudFormation template where they're defining the metadata themselves, or a Azure Resource Manager template where they're doing that. So again, it comes down to what the actual skill sets of these teams in your organization look like. There are a lot of different ways that metadata can actually get created and managed.
Right. So that metadata then, how does that get into the Juniper product? so that I can, so if I'm operations or security, how do I then use the tag that was applied in a Kubernetes environment or say in vSphere? Because those are very different infrastructure environments. How do I know that that metadata is a tag that relates to, say, a SQL server?
Right. So that is all done through the policy enforcer. So the policy enforcer component, which we're going to be demoing here in a moment, is going to go out. You'll create a connector where you assign it's just like an application token that assigns that to your account in your cloud environment. And then it's going to go out and periodically pull that account looking for the tags that are defined in that account. And then when you go into Security Director to create policies, those tags will be populated as potential match conditions when you write security policies. So basically, we've got this little, or the policy enforcer acting sort of like an API gateway that's constantly pulling our cloud providers to get the current set of tags that are available.
Okay, if you could show us that in the demo, that would be cool.
Yep. Yeah, definitely going to do that.
Just to that model, I think it's super powerful to have these tags. The problem that I see is more a cultural problem. There will always be people that assigning, let's say, unsecure tags, which were giving them a lot of access. And back in the traditional model, we had security people, which were kind of the auditors also for the rule set. Here, I think a lot of things needs to be audited afterwards, which tags have been assigned and who has the power to assign these tags.
Yeah. And you hit on something really important, which is that DevOps in general, which is something we're touching on here, a lot of that is about culture. It's really about having buy-in from everyone involved as to how this is supposed to work. So part of that is really getting people past this idea that as a developer, security is in my way, right? They're always holding me back.
Can you make me this one tag that is allowing everything? I will just use it for one test,
And then it's for everything.
Exactly.
Yeah, exactly. Yeah, so part of this, and part of what we're hoping to do by making this collaboration easier is help overcome this perception. As the security is the department of no, that they're just a pain, getting in the way, slowing down productivity. So like that culture thing is a really important thing to hit on, because that's not going to change just because we're using metadata tags, right? Like you said, you can create this magic tag that just allows access from everywhere for everything because it's easier. But this is one of the tools to help enable that sort of cultural shift. That's the goal, at least.
I think also for security people, back in the days, we were also, let's say, configuring the security policies and had kind of been involved in every of these actions. Now I think a lot of more auditing will need be part of the security team to watch who is really taking which predefined tags and who is assigning what.
Yeah. And it might make sense to have part of the team assigned to checking up on the tags that your developers are adding to their resources. And there are ways you can enforce this. You could check before any of these are deployed that they have the correct tags, that, maybe if we see 50% of our tags are this magic allow everything tag, we might want to go check to make sure that things are okay. So yeah, absolutely. That's an important consideration. All right, cool. So what we're really trying to enable here in the security context is a single policy set, regardless of data location. So this is the ideal goal. The degree to which we can achieve this will, of course, vary by environment, but we want to have a single policy across all of our deployments. So regardless of which cloud it's in, or whether it's even on-prem, we use the same policy. We're going to do that by leveraging tags instead of traditional IP matching in security policies. We're going to automate the whole thing using our policy enforcer tool. And part of this also is the remediation, the actual quarantining of infected hosts. So we've talked about this in the context of hardware enforcement on switches or NACs. Here we're going to look at actually putting cloud resources into isolated security groups to accomplish the same thing. So we want to be able to no longer have to look up IP addresses for specific hosts. We want to be able to work with cattle rather than pets is another way to think about this. We don't want to have to manually update all these diverse systems. We don't have to wait for threats to move through a security system. So we don't want to have to wait for it to propagate before we can do something. And we want to be able to work with our existing network and infrastructure. So this is where the policy enforcer comes in. We've introduced this component before. Here we're expanding the picture a little bit. So the policy enforcer really is sitting in the middle here between our ATP services, whether it's the ATP cloud or on-prem with the JATP appliance, that's analyzing our potential threats. So inspecting file downloads, for instance, getting up-to-date CNC feeds, and then enforcing that on enforcement points on premises, routers, switches, firewalls, or in the cloud, whether we're on AWS, Azure, or in a private cloud on OpenStack or vSphere. So here we have an example of what a threat remediation might look like. This example uses switches. The demo we're actually going to go through will be doing this in the cloud. So we start by having a user here try to download some malware. So they try to download something suspicious. Through the SRX, that's going to trigger an advanced anti-malware policy. We're going to send that file to ATP for analysis. This could be the ATP appliance or the cloud. In this case, ATP does detect some malware, so it's going to return a verdict. We discussed those earlier. So it's going to send information back down saying this is the expected threat level, this is the risk level, and then our policies will determine what risk level will cause us to actually quarantine a device. So that goes into our policy enforcer. If that matches a policy that says this is a threat level of 7, we're going to quarantine all threat levels over 6, then the policy enforcer does the work of actually deploying the isolation. So if this is a EX switch, that's going to be a firewall filter, just a Juniper ACL. Third-party switch, that might be an ACL, that might be an entry in a NAC database. We might block it, just deny the MAC address or OVSDB. A lot of different ways we do this depending on the actual target hardware. And then the infected host point will be quarantined, or endpoint rather, will be quarantined at the port level. And this can take a few minutes on average. It's going to vary depending on how long it takes to actually detect the threat.
Question on the, when you quarantine and it's a wireless device, how do you quarantine that and make sure that it's not going to be a client misbehave on your wireless network?
Yeah, so I don't know, do we have Mist integration yet?
Yeah, so that's a really good question, right? Because you don't want to cut off access to the entire access point, the hundreds, thousands of users that might be using that one. So when it comes to the wireless piece, this is where we're integrating with Mist. And we're still working through all the details of that, but it'll likely just be a deauth for that specific user rather than a switch port level type of blocking with like a dynamic ACL.
But even then, if that client is being de-authenticated, if it's an aggressive client like a mobile device, it will continuously try to re-authenticate, which is going to give a lot of authentication failures in your log. How do you cope with that?
So that's actually one of the brilliant things about Mist, right, is that it again leverages a lot of machine learning and AI as well to figure out, well, if we have this happening, it'll start to alert the administrator to, hey, there's a problem here. And from and I hate the word single pane of glass, but that's probably what we're doing from a management system wise, is the way that the integration will work is Mist has kind of the idea of on a per user level, or I should say user, because device, right, on a per device level, because this also applies to things like IoT devices. You can see all of the potential network issues, right, whether that be authentication issues, whether it be issues with DNS or DHCP, things like that. It'll show you here's all of the potential, or here's all of the network issues that it's observed with that specific endpoint, but there's also here's all the security issues. And so in one place you can see, why isn't this user, like, why are they complaining? Why might they not be able to access the network right now? Is it a network-based issue or is it a security-based issue? And then we can kind of make a decision on what needs to happen from there.